I once tried to use this tiny pocket-sized dictionary to translate a really complex dinner menu in a foreign country.
Oh boy, I can see where this is going.
Yeah, I thought I was confidently ordering like a simple roasted chicken. But because I was just translating word by word, I ended up with this massive, steaming platter of fermented tripe. And, well, what I'm fairly certain were duck feet.
Right, because you had the individual vocabulary words, but you were completely blind to the grammar, the actual context of the sentence.
Exactly. And I learned the hard way that understanding a new language is nearly impossible without that surrounding context. So today's deep dive is about learning a much more important language. We are talking about the complex grammar of the tumor microenvironment.
It really is a fascinating leap in how we interpret biological data.
Yeah. Our mission today is to explore how Microsoft Research's incredible new AI model, GigaTime, is unlocking the future of precision immunotherapy.
It is just wild what they are doing.
But hey, decoding a complex language is tough. Honestly, it is almost as complex as trying to figure out where AI agents could make the most impact for your business or even your personal life.
Oh, absolutely.
So if you need help with your own AI training or automation, integration, software development, you should check out our sponsor, Embersilk. At embersilk.com has you covered for all your AI needs.
They do great work.
But getting back to the medical data, if you or a loved one needs a biopsy today, your doctor is usually forced to choose between a really cheap test that misses the big picture or a comprehensive test that, bankrupts the hospital, right?
Yeah. That is the core bottleneck we are facing right now, because standard pathology relies on H&E slides.
Those are the basic pink and purple tissue stains, right?
Exactly. Doctors have used them for over a century, and they are incredibly cheap, maybe $5 to $10 a pop.
Wow, okay.
But they only show basic cell shapes. They completely miss the complex immune details. So to map out exactly how a tumor is interacting with the immune system, doctors need something called multiplex immunofluorescence, or IMF.
Life, right.
Right. It acts like a high-tech filter, highlighting 21 different protein channels. But getting that MIF data costs thousands of dollars per single tissue sample.
Thousands. So, okay, it is basically like having a cheap, grainy, black and white security camera feed and trying to use AI to instantly generate a high-res 21-channel 3D radar map of the exact same alleyway.
Well, the radar analogy is close, but it is really more like having an AI that can look at the physical brushstrokes of a black and white sketch and perfectly guess the original chemical colors.
Oh, that makes sense.
Yeah, GigaTime is looking at morphology. So the physical shape, size, and clustering of the cells in that cheap $5 pink and purple slide. They trained an AI on 40 million cells.
40 million.
Yep, so it could learn to correlate those physical clues with the invisible protein signatures. And that creates a highly accurate virtual MIF image.
Wait, hold on. If we are using AI to effectively guess or generate a 21-channel image from a basic stain, how do doctors know they aren't looking at a mirage?
That is such a good question.
Because, in medicine, an AI hallucination could easily lead to the wrong chemo treatment for a patient.
Right, and that is the exact right concern to have when introducing AI to healthcare. But the researchers didn't just assume it worked.
I think I could.
They rigorously tested it by applying GigaTime to over 14,000 Providence patients.
Wow.
Generating 300,000 virtual images. Then, they independently validated the AI's accuracy on another 10,200 patients. It wasn't hallucinating, it was finding actual, hidden biological ground truth.
That is amazing. And because this translation drops the cost from thousands of dollars down to just $5, that completely changes the scale of what hospitals can actually afford to test.
Exactly. That scale is where the real breakthrough happens. Instead of looking at a few dozen expensive physical samples, researchers suddenly have a virtual population of tens of thousands.
Which is a game changer.
It really is. At that scale, GigaTime uncovered over 1,200 statistically significant associations between immune cell states and clinical biomarkers, things that were previously invisible to us.
That is wild. Give me an example, what kind of associations?
So it comes down to combinatorial power, for instance, looking at proteins like CD138 and CD68.
Okay, what do those do?
Think of these as specific ID badges worn by different types of immune cells. GigaTime proved that mapping these two specific ID badges together in the tumor microenvironment predicts patient outcomes significantly better than tracking any single marker alone.
Oh, I see. because you were finally seeing the whole conversation between the immune system and the tumor, not just the isolated words.
Precisely.
Mm.
And Microsoft has actually made GigaTime entirely open source.
Really? That is huge.
It is. It accelerates global research toward creating a digital twin or a virtual patient. We are moving toward a reality where we can accurately forecast how your specific tumor will respond to a treatment before you even take a single pill.
What an incredibly hopeful future for human health. I mean, we are actually gaining the tools to conquer cancer.
So we are, which
No,
leaves us with a really fascinating thread to pull on. If AI can translate a routine, century-old $5 slide into a highly personalized map of a tumor's immune response,
Yeah.
what other hidden biological languages are just sitting there, waiting to be translated in our everyday medical data?
Oh, what a brilliant and optimistic thought to leave on. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out to other intellectually curious listeners. Thanks for tuning in, and remember, with the right AI translation, we are one step closer to curing the patient, and, well, one step further from accidentally ordering the fermented tripe.